So in part two of our dimensional analysis lesson, we are going to take a look at more complicated problems, multiple units and so forth. So here's where we're going to start. So in the past, a couple of examples, I've given you one unit to one different unit. Now, if you take a look at the question, I have miles per hour. So I have 2 units in a problem going to how many meters per second. And like I told you before, I'm not going to make you memorize any conversion factors except those 5 for the metric system. So there's 1.61 kilometers in 1 mile. So we're going to need to use that one at some point. All right, so how am I going to start this question? It looks way more complicated. Well, what I'm going to do is I'm going to write 65.9 miles, and notice the per, it's really per 1 hour, right? I have a denominator now. So whenever you see a problem with units something per something, you have your denominator. Don't put this all over 1. That's going to mess you up royally. Okay, so this the slash there is telling you there's the fraction, there's the division sign. Okay, so 65.9 miles per hour. Over here, I have to get meters on top, seconds on bottom. So it makes sense. Hours to seconds in the denominator, miles to meters in the numerator. Okay? How do I do this? I don't have to do it all at once. I'm going to do 1 unit at a time. So let's do the miles first. So we're going to pretend that hour isn't even there. I'm just going to focus on the mile part. So I know from this conversion factor that 1 mile is equal to 1.61 kilometers. Okay, miles cancel out, and I would have my answer. If I stopped here, my answer would be kilometers per hour. It's not what I want. I want meters per second, so I'm not done yet. But that's what, just ignoring this unit just lets it sit there. Okay, so kilometers, I got to get to meters, so I know that in 1 kilometer, there are 1,000 meters, whoops, 1,000 meters, I'm thinking centimeters, 1,000 meters per 1 kilometer. So again, kilometers will cancel. If I stopped here, I'm in meters per hour. I don't want meters per hour, I want meters per second. Okay, so now I know that there are in 1 hour, so notice what I did. Hours in the numerator here, I'm sorry, the denominator here, I have to put it in the numerator over here. So now hours will cancel. I'm going to go to minutes because I know that right off the top of my head. And then to get minutes to cancel and get to seconds in the denominator, I know that there's 60 seconds in 1 minute. So minutes will cancel, and what am I left with? I'm left with meters per second, which is what I want. So now it's simply a matter of doing the math. So I've got 65.9 times 1.61 times 1,000 divided by 60 divided by 60. Oops. 60. There we go. 29.4719. How many digits am I allowed to have? Okay, all of these, even this one, we did kind of round this one off. It's actually 1.6091 something something something. We're going to kind of ignore the fact that we rounded this guy off. We're going to let this control it. So 3 sig figs here, I need 3 sig figs here, so I'm going to go to 29.5 meters per second. Okay? So don't let the fact that there's more than 1 unit confuse you. You just handle them one at a time. Okay, so here's the next one. We're taking a density in grams per centimeter cubed and making it centigrams per centiliter. This is a really good conversion factor to have in your head. 1 cubic centimeter is equal to 1 milliliter. That will let you get back and forth between volume and cubic length. Okay, so this is a really good number to have in your head. I'm going to suggest that you memorize that one. But let's look at what we're starting with. We've got the 27.3 grams per centimeter cubed in the denominator. Okay, I've got to get to centigrams, so I'm going to take that one first. So grams to centigrams, not meters, grams to centigrams, I know that there are 100 centigrams per 1 gram. So grams cancel. If I stopped here, it would be centigrams per centimeter cubed. It's not what I want. I want per centiliter. Okay, so centimeters cubed is equal to 1 milliliter. So that's going to get me to the volume expression. So centimeters cubed will cancel. Milliliters to centiliters. You don't have to know this one, but you may. You know, centi is 100, milli is 1,000. So there's 10 millis in a centi. So if you want to do it this way, absolutely okay to do that. Your other choice is to go to the base unit. Okay, so you could do 1,000 milliliters per liter, because that's one of the conversion factors you need to know. And then you could do 1 liter per 100 centiliters, and that takes care of both of those units. So either way is okay with me. If you know this off the top of your head, don't start trying to do ones that you may not be comfortable with. It might just be easier just to write them both out. All right, so then if I do the math, I've got 3 sig figs in my answer. Oops. Times 100 times 10. So 27,300. I'm not going to put a decimal point in there because I only want 3 sig figs, but that is centigrams per centiliter. Again, not a really logical. This one is a very logical unit set. This one not so logical, but you know, we're practicing doing this unit conversion stuff, so I got to throw some stuff out there that doesn't make quite so much sense. All right, so that's how you're going to handle multiple units. Next one, we're taking it up a notch. Okay, so take a look at what you've got. 2.5 grams per centimeter cubed, so there's a density just like the one above. It's the same as how many kilograms per meter cubed. Okay, so notice I don't need to use this conversion factor. I'm not going from centimeters to liters or milliliters. I'm going to meters cubed. So how do I get from one cubed unit to another? Here's the increased complexity. How do we handle that? So I'm going to start off 2.50 grams per centimeter cubed on the bottom. That's a 3. I know it doesn't look too much. I want you to remember that centimeter cubed is really centimeter times centimeter times centimeter. That's what you've got to remember to do a conversion like this. So you might have centimeters squared, you might have centimeters cubed, or you might have whatever squared, whatever cubed. You've got to remember that that cube and that square is that many times the unit that you have. All right, so let's do the easy part first. Grams to kilograms. I know that there's 1,000 grams in 1 kilogram. Grams on the bottom will cancel out the grams in the numerator, and then I'm left with kilograms. Okay, now I've got to deal with this square thing. So if I say there's 100 centimeters per 1 meter, how many of the centimeter units has that just taken care of? Just 1, right? So 1 of these cancels out. If I were to stop here, my unit would be kilograms per meter centimeter squared. I still have 2 centimeters that I got to get rid of, which means I have to do this conversion factor 3 times. Okay, so 100 centimeters per meter takes care of the second one. 100 centimeters per meter takes care of the third one. So now I've got meter times meter cubed, because that guy got crossed out, and I have kilograms, so now I'm in the right units. Okay, some of you might say, well, can't I just cube it? Can't I just say this? 100 centimeters per meter and cube it, right? The problem is you didn't cube the number. You also have to cube the 100. So you've got to remember that if you want to write it that way, you also have to cube the number. A lot of kids will forget that part, so that's why if you write it out, you're more prone not to. I don't care which way you do it as long as you do it right, but if you try and do it this way and you forget to cube the actual number, your math's going to be wrong, you're going to get it wrong. So it's your choice, but just be careful, okay? And if I calculate it out, I get 2,500. Oh, but I got 3 sig figs. 2,500, but I got 3 sig figs. So how do I write that? One of these zeros has to count, the other one doesn't. So hopefully, with a pause, she says, you know that you're going to have to put it in scientific notation. 2.50 times 10 to the third is the same as 2,500. And what are my units? Kilograms per meter cubed. Okay? All right, last one on this page. So we got 4 more to go because we're pumping it up a couple notches each time. All right, this looks crazy, doesn't it? I've got so many units here. Kilograms and meters squared are on top, seconds are on bottom. I've got to get that into a different version of grams, oh, I kept it as meters. Let's make it centimeters, because that's no fun. And seconds squared to minutes squared. Okay, so again, it looks complicated, but do 1 unit at a time. 4.184 kilogram meters squared per second squared. That's what it should look like to start your problem off. Seconds are on the bottom, kilograms and meters are on top. Okay, do it 1 at a time. Kilograms to grams. There's my conversion factor, gets rid of kilograms, gets me to grams. Okay, meter squared to centimeter squared. So it's very similar to what I did up here, except I'm just squaring it. So for every 1 meter, I have 100 centimeters. But it's squared, so I'm going to do that twice. So that gets rid of the meters squared. Second squared's on the bottom, so I'm going to have to put seconds up here. But they're squared again, so I have to do it a second time. Which gets me to minutes squared. So my units are going to be grams, centimeters squared per minute squared. Now I just have to do the math. So I'm going to have a big number. Look at all those things. 4.184 times 1,000 times 100 times another 100 times 3,600, because I'm doing that in my head, gives me, so 4 sig figs, 1.506 times 10 to the 11. That's a big number because we went to really little units. All right, so hopefully the multiple units is making sense. Now the squares and the cubes, it's just another set of multiple units, just expressed a little bit differently visually. Just a bunch of multiple units. The last section that I want to do with you guys is going to have to wait till the next video because I'm running out of time.